Good morning, everyone. I hope you all are fine and staying home. Today is our second lecture on PERT, and in the previous lecture, we discussed the historical background of the PERT and we also discussed some important concepts related to PERT. Today, we'll discuss a problem, but before that, I'll tell you the basic difference between the CPM and PERT, as I already have told you that both are quite similar to each other. There in CPM, I told you that each and every activity timings are deterministic in nature. That is, for each and every activity, only a single duration will be given, and with that, we have to proceed everything. But here, in case of PERT, each and activity will have three time estimates. First, TO, that's optimistic time, which is the least time that an activity takes. Second is TM, that's most likely time, and this is the time required to complete the activity, but under normal circumstances. Third is our TP, that is pessimistic time, and given the worst conditions, what is the time the project is going to take? We have discussed all these three time estimates in detail in our previous video. I won't elaborate them here. Let's now move to the problem. This is the problem that we are going to discuss today. Here you have been given the activities, and for each activity you can see the predecessors are given, and here time duration is shown in the weeks, and as I told you that three time estimates are given for each activity, that's optimistic time, most likely time, and pessimistic time. Now with the help of this information given in the table, we will first construct the project network. Second, we'll find the expected duration and variance of each activity. And lastly, we will find the critical path and expected project completion time. First, we will just construct the project network diagram. And for constructing the project network diagram, we need two informations. First is the activities and second is the predecessors, like this. Alright, and with the help of this information given in this table, we will construct the project network. Let me first explain you the data given in the table. Here you can see there are 10 activities A to J, and for each activity predecessor is given, right? For activity A, B and C, you can see there's no predecessor at all, and for activity D, it has A as its predecessor. That means A has to be started where, D has to be started where A is ending, and the same way E is having B as its predecessor, F is having C as its predecessor, and so on. And you can see here activity H and activity J both are having two predecessors. Like, let's start our activity, and you are now aware that for starting and for each and every activity we need two nodes, that is the start node and an end node. So here again we'll need a one node to start an activity, and that will be our node 1, like this. And from here we will start an activity A, because A is having no predecessor, so this will start from node 1, like this. And as each and every activity is having one start and one end node, so A is having 1 as its start node, and this will have 2 node as its end node, right? Now activity B, again having no predecessor, this will also have to start from node 1, like this. And as our previous activity A was ended at 2, this will end at node number 3, like this. Now activity C, again having no node, so this will again get started from node 1, like this. And as our previous activity was ended at 3, this one will end at node number 4, like this. Alright. Now activity D is having A as its predecessor. That means we have to start D where A is ending, right? Let's find the A first. A is here, it's ending at 2. This means we have to start activity D from node number 2, like this. And as our previous activity was ended at 4, this activity D will end at node number 5, like this. Alright. Now activity E is having B as its predecessor. That means we have to start B from node number 3. That's where B is ending. So B is ending at 3. Activity E will get started from here, like this. And as our previous activity was ended at node number 5, this one will end at node number 6, like this. Now activity F is having C as its predecessor, and if you can see, G is also having C as its predecessor. That means both these activities, F and G, will get started from node number 4, where C is ending. That's from here. Let's first start our activity F. It will get started from node number 4, like this. And why I ended it at node number 6? If you can look here in the table, activity H is having two predecessors, and E and F are ending at same node, right? So E we already ended at 6. That's why I ended node F on the same node. Alright. Now activity, we completed F, now it's G. Activity G is again having C as its predecessor. C is ending at 4, so it will get started from 4 like this. And as our previous activities, E and F are ending at node number 6. This one will end at node number 7 like this. Alright. Now activity, it's G, now H. Activity H is having E and F as its predecessor, right? That means where E and F are ending, we have to start H. Like E and F are ending at 6, we have to start H activity from node number 6 like this, and it will end at node number 7. Now why I ended it at node number 7, you can see our last activity, it has two predecessors H and G, and both are ending at the same node. As already G was ended at 7, so we have to end activity H at node number 7. Alright. Now after H we have activity I, and it's having D as its predecessor. That means where D is ending, we have to start I. Let's find the D first. D is here and it's ending at 5. That means we have to start activity I from node number 5 like this. As our previous activity was ended at 7, this will end at node number 8 like this. And our last activity J is having two predecessors H and G. So where H and G are ending, J has to be started. So H and G are ending at 7 and J will start from node number 7 and it will end at node number 8 because we don't have any activity left. So this has to be ended at node number 8. This way we successfully constructed the project network diagram, and you can see the whole project is complete and having one start node, that's node number 1, and the whole project is ending at node number 8, that is the last node of the activity. This way we complete the first problem, that is the construction of the project network. Let's move towards the second problem, that is to find the expected duration and variance of each activity. Let's have a look on a table first. This is the table where activity is duration, mean and variance, because we have to find the mean and variance of each activity. I have skipped the predecessor part here because we don't need it now. We already completed that part in constructing the network diagram. Here we have to now calculate the mean and variance of each activity. Let's first find the mean of the activity, and here is the table. We have to now find the mean for each activity, and to find the mean we have to follow a formula, that is TE is equivalent to TO plus 4TM, that's 4 multiplied by TM, plus TP divided by 6, where TE is expected time and TO you already are aware that TO is optimistic time, TM is most likely time, and TP is pessimistic time. And activity, let's now apply this formula and try to find the mean for activity A, and the information is given here. We have all three time durations given here. Let's apply this formula for activity A, and it will be like TO is 1, that's 1 for activity A, TM is 3, that's TM is 3 for activity A, and TP is 5, that's 5 for activity A, TP is 5. Alright, divided by 6. Let's calculate it further. It will be 1 plus 4 multiplied by 3 are 12 plus 5 divided by 6. And it will be like 12 plus 5 is 17 plus 1 is 18 divided by 6, and our calculated mean for activity A is 3, right? And you have to mention these 3 as here. This way it's very easy. You just have to apply the formula and calculate the mean, and now you can calculate the mean for each and every activity. Here I already have calculated the mean for each activity and the values are like this. You can now see the calculated mean for each and every activity. This way you can calculate the mean, and now we'll calculate the variance in the same way for each and every activity. And for variance you also have to follow a formula, and that is square of HD is equivalent to TP minus TO divided by 6 whole square, where TP is the pessimistic time, TO is the optimistic time. Let's now try to calculate the variance for the activity 1 and the data we have already given in the table. It will be like TP is 5 for activity A and TO is 1 for activity A, it's given here, divided by 6 whole square. It will be 5 minus 1 or 4 divided by 6 whole square, and the calculated variance for activity 1 is 0.44. that is, you have to mention it here. So this way we calculated the variance for activity A, and it's very easy. Just by applying the formula, you can calculate the variance for each activity as well. And here I already have calculated the variance for each activity, and the values are like this. You can now see the calculated variance for each activity as well. This way we completed our two problems, that is the construction of the project network, and second we completed the expected duration. We find the mean and the variance of each activity. I'll stop it here because the video is going too long. Tomorrow we'll find the critical path, and you know the critical path is the longest path, and we'll also find the expected project completion time. I'll see you tomorrow again. Till then, take care and stay safe.